Hello. Hi everyone. Good evening. Am I audible and visible to you? You can give me thumbs up in the chat. Yeah. Okay. Okay. So all are excited for today's session? Okay. So without delaying, let's proceed with the day 2 of our DSA with Java Bootcamp. So today we will be ideally covering time and space complexity. Then we will be heading towards searching and sorting related concepts. And then we will solve few of the practical interview related questions. Okay. So before that, yesterday we had covered array and string related basics, right? We understood what are arrays, then how do we use and implement one dimensional and two dimensional array, then how practically arrays are useful. We have understood that. Then later on we have moved to string related concepts. So ideally, what are the ways to declare the string, how string is internally stored in the memory, then how do we use string builder and string buffer, what are their use cases. We had implemented till that in the yesterday's lecture, so today we'll be covering the topics ahead of that. Okay. Any doubts till the topics we have covered, like from the yesterday's session? Anything you want to repeat or revise? Okay. So by chat, I can't see any doubts till now. Okay, okay, fine. So without delaying, let us proceed with the day two. Okay. Let me know once my screen will be visible to you. Is it visible? Yeah. So okay, so about string builder and string buffer. So we understood that string is immutable. That is, we cannot modify the string once after declaration, right? The string is immutable, like we cannot change the existing string. Okay. So if you want to modify the string, in that scenario, the new string, new object is created every time. So that consumes a lot of memory and also will take, like, the performance will be slower in that scenario. If you will use string and you will modify that string every time, then that is like, it is complex operation because it will create new objects as well as it will take more performance, or it will be slower. So that's why we have two different classes, which are string builder and string buffer, which are used to create the string. So in that scenario, when we use string builder, uh, you can modify the existing string, your string becomes mutable. And additionally, there are other operations as well, like insert, delete, remove. So you can perform all those operations on the existing string without creating new object. Buffer is also similar, only there is one difference between builder and buffer, that is, string buffer is thread safe whereas string builder is not thread safe. So as per your use case, you will be choosing string builder or string buffer. Okay. And if you want constant string, which you will not be modifying throughout the program, in that scenario, you will use string variable itself. Okay. But if you want mutable string, then either use string builder or string buffer. If you want good performance and if you are not concerned about the thread safety, then go ahead with string builder. But if thread safety is your concern, if your application is multi-threaded, in that scenario, you have to use string buffer. Okay. And we had also learned about string constant pool and heap memory. So whenever we create the plain string, like with the help of string keyword, let's say I'm just storing hello to this variable. So in this scenario, where will the object be created? Can you suggest on the same. Where will the object be created? I'm just declaring one variable hello. So ideally in the memory, where will this object get stored? Right, string constant pool. One object will be created in the string constant pool, because string constant pool is kind of the memory, kind of the place which keep the track of all the string variables in your program. Okay, so let's say if you will create 10 different string values, then all those string values will be stored into string constant pool, but it will only store unique values. Okay, only one entry of the string will be added into the string constant pool. Okay, let's say I'm creating one more variable with the help of new keyword. Okay, so here I'm using string class instead of literal, and in this one I'm storing word. So when I'm creating the string in this manner, so how many objects will be created and where will those objects be stored? Ideally where it will create the object. uh, no, non-constant pool, there is no such area. Okay, we have only two areas, which are string constant pool, which is also called as scp, and another one is heap memory. So string constant pool creates entry every time. Okay, so when I am creating this variable, one entry will be done into the string constant pool, because it is new entry, right? Hello will not be already present into scp, so that's why it will add world into scp, and one more object will be created into heap memory, because we are using new keyword over here. Okay, so by this statement, ideally it will create two objects, one in the scp and one in the heap memory. Okay, so do remember this concept and understand it very well. Okay, yeah, if I will create, let's say, just to give an example, I have two objects. Okay, so and one more object I have. So in this scenario, overall, how many, in total, how many objects will be created? You can respond in the chat. In total, how many objects will be created? Yeah, after this question, we will be starting with today's topics. Yeah. So by this, how many objects will be created? Four. Right. Where will those four objects be created? Ideally, two in the string constant pool, because both are the unique entries. There won't be entry of my str into scp and new str into scp, so that's why two objects will be created into scp, and two objects will also be created in the heap memory, because we are using new keyword over here. Okay, so that's why two objects will also be created into heap memory. Okay, is everyone clear about this concept? Should we can go ahead? Okay, so we were discussing about problem solving yesterday. So we are aware that nowadays any interview we will appear, or any coding round we are appearing for, there they will ask us the questions about problem solving, right? They will give us few questions to solve, problem statements to solve, and you have to give the logic for the same. You have to develop the logic to get the respective output. So how they will recognize, like, you have write the efficient code or not, or how better is your code, how good logic you have added in your program? How do they identify that? So I was saying that you will develop the program, right? Then how the interviewer will judge your program, that your program is correct or not, or how good it is, like how efficient it will be when execution, right? Yeah. So there is the, like, every time the interviewer will judge your program based on the two things, which are time and space complexity. Okay. So two things are concerned to judge the quality of your program, which are time and space complexity. So this seems to be very, like, big words, right? So what is ideally time complexity, and what is space complexity? Whatever you know, whatever you are aware about. I don't want the specific or correct answer. What are your thinkings about those two words when you say about time and space complexity? Correct. You have correctly responded that it is the time taken to execute the program. So is it like I will develop the code and I will execute the program and it will take some time to run that program? Is it that time that we will consider? Ideally, no, because different operating systems will take different time to execute the program. Let's say I have the system with high configurations, uh, which is latest, and with latest configurations, that will ideally execute my program faster, right? Then compare to the system with lower configurations, correct? So ideally, like, it is not the time which is taken for execution of the program, it depends on the input. Okay. So ideally, the time complexity is how much time your program takes to execute with respect to the input you are providing. So it is measured based on the input value. Okay. So we can say the rate at which the time increases with respect to input. So if my input increases, ideally my time should also increase. Okay. So what, to be specific, we can say time complexity is rate at which time of execution increases with respect to input. So to draw the relationship between this, we ideally develop the graph between the time taken and the size of the input. Okay. So yeah. So this is how we identify the relationship between that. So in the layman terms, you can understand that, let's say if I am giving two values as the input, okay, or I am processing 10 values, then ideally my program will take more time than one value, right? If I am providing just one value as an input, it will execute faster. And if I will give 10 values as an input, then it will take comparatively more time, right? So it is like the relationship between the input and the time taken. So as input increases, the time will also increase. So ideally, you have to develop the algorithm, you have to develop the logic so that it will produce, like, it will take lesser time to execute. It will give good performance during execution. Okay. So like, we draw the line to represent the relationship between the input data and time. Let's say initially, if my input size is 1, here I am giving input as 1, so it is taking this much amount of time. Okay, then I increase the input. I am giving the like 5 values I am giving as an input. So ideally it will take more time here as well. So like, as the input is increasing, time also increases. So we will ideally draw the line which will be the common between them. Okay. So this line will indicate the rate of increase, we can say, with respect to the input, rate of increase in time with respect to input. So ideally we have to develop the solution, we have to develop the logic so that the this angle will be lesser. Okay, so here, like, to denote the time complexity, we use big O notation. So big O notation is used to give time complexity. We have different units, right? To identify time, we use hours, minutes, seconds. Similarly, to identify time complexity of any algorithm, we use big O notation. It is used to give the time complexity of the program logic or the algorithm. Okay, it is given in this manner, O, and whatever is your time complexity, you specify over here. Okay, so there are different time complexities of different algorithm. Here they have given generic time complexities. O1, it means your algorithm is taking constant time to execute. Then log n, it means logarithmic time. Then on, it means if there is only one loop involved, then it will take the like if n number of values are taken as an input, then the time complexity will be on. Okay, so in here are the increasing time complexities, they have indicated by this graph. Okay, so here you will mention O. A big O notation is given in this manner. Give O first, and in round brackets you have to give the time complexity. So let's say I have one for loop in my program. So the time complexity will be ideally n, because I will take n values in that for loop. Okay, so inside round brackets we will simply give n over there. Okay, so depends on the code logic you have given in the program, we determine the time complexity of the respective program. Okay, so ideally you should develop the program so that the time complexity should be lesser. So the program with time complexity with O1 will be more efficient than the program with time complexity On. It will execute faster than the time complexity On. Okay, we will see one example so that you will understand how to calculate time complexity. Okay, so let us write the program to find out the element in an array, to search the element in an array. Okay, yeah, so alpha and beta notations are also there, but ideally when you calculate time complexity, we always consider worst case scenario. Okay, so ideally there is worst case, there is average, and there is best case. So what is worst case, what is best case, and what is average? So ideally when you are, let's say I'm writing the program to find out the element in an array. Okay, and in that scenario, if you are getting that element at the first position itself, it means it is best case, right? You don't have to traverse through the entire array. At the first position itself you find out that element, so that will be best case. Average will be, let's say, in the middle of the array you find out the element, so that is average. And the worst case is like you have to traverse through the entire array and the last element was the one which you were searching for. Okay, so always while calculating time complexity, interviewers will never ask you about average or best case. They will always ask you about the worst case scenario. Okay, so ideally we consider worst case only while calculating the time complexity, and we denote the worst case time complexity with big O notation. For average and best case, we have theta and omega. Okay, but ideally we deal theta, and we have ohm as well. But for worst case, we deal with big O notation itself. Okay, so okay, let's proceed. So we are just writing the program to search the element from the array. So ideally for searching, we have few algorithms. Are you aware about those algorithms? Which algorithms we use to search the element or from the array? There are few predefined algorithms to traverse through the array and check out for the element in an array. Are you aware about that? You can give your inputs in the chat box. Which algorithms are used to traverse through the array and search an element? Search means you have to find one element into that array. Yeah, so we have linear and we have binary search. Correct. Linear search and binary search. So what is difference between them? What is linear search and what is binary search? So linear search is, it is like the generic approach which we do. We traverse through each and every element and we look out for the element which we are looking for. Right. First element, second element, likewise we will go ahead and we will traverse through the array. That is linear search. And coming to binary search, in case of binary search, what are the peculiarities? What do we do ideally? What is the logic of binary search? Okay, let us first proceed with linear, then we will come to the binary search. Let's say we want to return the index at which the element is found. Okay, so here the return type will be integer. We will be returning the index at which the element is located. Okay, we will pass the array as an input to this function. Okay, so we have to perform linear search. It means we will simply traverse through the elements. We will look out for the element which we are searching for, and wherever it is found we will return the index of that element. Okay, so we will pass one more input over here. Right, so simply what we will do, we will use one for loop to traverse through the elements. Let me once save this program. So we will be saving with the same name with which we have created the class. So demo.java. Yeah. Okay. So we have to search this element into the array. Okay. So simply in the if condition, I will give the same if lm equals to a of I. A of I will give me the element at that position, and I'm comparing that element with the element I'm searching for. Okay. So wherever the element will be found, we will simply return that index. Okay. And if the element is not found, we will simply return -1. Okay, so this is simple algorithm for linear search. We traverse through the array, we look out for the element we are searching for, and we will return the index at which the element is found. Okay, let's run this program. uh, let's first declare the array. Yeah, we are declaring and initializing here itself. Yeah, so let's say uh, let's call out this function which we have created. Yeah, we will pass the array and the element which we are looking for. So here we are looking for, let's say, the element 9. Let's run the program. So here we have got the index of the element, right? The 9 is at index 2. So we have got the respective output over here. Let's say I'm finding the element 11, which does not exist in my array. So ideally it should return -1, right? Yes. So accordingly, it has written -1 over here because that element is not found in the array. Okay. Yeah. So let us find out the time complexity of this algorithm. So ideally, what is time complexity? It is how many steps we are performing, right? So ideally, in this logic which we have written, what are the steps which we are performing? We are initializing the array, then we are checking one condition, we are performing increment, and here we are validating one condition. So ideally, step 1 is check the condition. If it is satisfies, we will go inside and will uh, execute this logic. So this will be step 2, and one more step which we are doing is increment. So this will be step 3. So ideally we are doing 3 steps. Okay, and this 3 steps will be repeated for the number of times as per the size of the array, right? So as my size of the array is 5 over here, so 3 steps will be repeated 5 times, right? So let's say my size is n. Let's consider that size as n. So ideally, I will be repeating the 3 steps n number of times. Okay. The same 3 steps will be repeated how many times? N number of times. So my complexity will be what? 3n over here. But while giving the time complexity, we ignore the constant values. Okay. So ideally, it won't be 3n, it will be n itself. Okay. We ignore constants. Okay, so that's why the time complexity of this operation, this algorithm which we have added, will be on. Okay, so everywhere when where there is single loop involved, there the time complexity is ideally n itself, and if there are like nested loops involved, it becomes n square because we repeat the logic for like 2 times for the nested loop as well. Okay, so if there are nested loops, the time complexity becomes n square. Okay, so depends on what algorithm you have added, the time complexity will be different for different logic. Okay, for single loop it will mostly be 3 o of n. Okay, so you have to develop your logic such that your time complexity will be towards this graph, towards this side, it will be lesser. Okay, O1 is the ideal time complexity, which is constant time complexity. Log n is for those algorithm in which we divide the array size, which is for binary search. For binary search, the complexity is logarithmic n. Okay, because there we divide the array into two halves, we keep on dividing the array half 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 every time. Okay, so your search space becomes smaller, it becomes half every time. So in case of binary search, your time complexity is log n. For single for loop, it is ideally n. Okay, for nested for loop, it is n square. Okay, and ahead when we will study recursion and everything, in those scenarios the complexity becomes 2 raised to n. In factorial it becomes uh, uh, like in backtracing and all those are like advanced concepts, so in those scenarios the complexity is more higher. Okay, so ideally we should develop the logic so that complexity should be this side, so that your performance of the program will be more better. Okay, yeah, and always consider the worst case scenario when you will write the logic and you will calculate the time complexity. You have to consider worst case scenario. Additionally, you have to ignore the constants, and one more rule is you have to consider bigger values. Okay, so let's say in your logic here it was only 3n, but let's say after calculation my equation is something like 3n square 5n, like this. So here n square and n is there, so in between n and n square, which one is bigger? N square is bigger, right? So I will not consider lower value, but I will consider the bigger value. Okay, so if my equation is this, initially I will remove the constant. So 3 and 5 will be removed first during calculation, then I have to ignore lower value, so n I will not consider. So ideally my time complexity will be n square for that algorithm. Okay. Yeah. So for single for loop, the time complexity is ideally n. Okay. For nested for loops, it is n square. For the algorithms where you are dividing the array into half and again calculating and dividing into half, in such kind of algorithms, the complexity is log n. Okay. So in binary search, we do the same thing. In case of binary search, what we do initially, in case of binary search, the prerequisite is the array should be sorted. Okay. Very first, your array should be sorted. After sorting the array elements, you will move ahead. So first step will be, you will check for the middle element of the array. You will see whether it is the one which you are searching for. If it is found, you will return that index itself. Let's take one input value so that we can get this in better manner. So let's say my array is having the values 3. My array should be sorted, so I will consider input values as a sorted. We will come to space complexity as well. Yeah. So this is my input array. So uh, when I am performing binary search, let's say I want to find out the element 5. My search element is 5. Okay. So ideally first step is, you can write the pseudocode for the same. Pseudocode is you like you identify the logic and then you develop the code for the same. Okay. So your step 1 will be check middle element, then check if it is the one which you are searching for. If it is, then you have to, like, there itself your program logic is complete. But if it is not, so here my middle element is 8, which is not one I am looking for, right? Then we will see whether the element I am looking for is smaller than or greater than the middle element. So ideally is 5 is smaller than the middle element, right? So in that scenario, I will be looking into this array, this side. So this entire part of my array will be skipped. Okay. That will be removed from the search operation. Okay. We will be looking into the left side of this middle element. Okay, we will search into the left side. So here again I will find out the now my search array will be this. Okay, so here I will check out for the middle element again. So as there are only two element, ideally my middle element, like we will do like first element plus second element divide by 2. So 0 plus 1 divide by 2 will ideally become 0. So again, so here my indexes will be 0 plus 1 divide by 2, right? So 0 plus 1 will be ideally 1 divide by 2. So 1 divided by 2 is nothing but 0.5, which will be rounded up to 0. Integer division returns integer itself. Okay, so the answer over here will be 0. So 3 will be my next mid element. So again I will see whether the middle element whether the search element I am looking for is the one which is middle element or not. If it is not, we will again identify the left and right side of that array, and again we will perform the same logic, same operation again. Okay, so that is ideally the logic of binary search. Okay, check middle element. If it is similar, then return the index. But if it is not, then we have to, like, if it is smaller, then we will look into the left side, and if it is bigger, we will look into the right side of the array. Okay, so we have to draft the same logic for the binary search. Yeah, we will return the index again. We will pass array as an input over here, and we will pass the search element. So both the ideally both the algorithms are doing the same thing. Both are finding the element, but time complexity is different for both the algorithms, right? And ideally, that algorithm is preferable, which has good time complexity, better time complexity. So when I am doing linear search, the time complexity is O n, and in case of binary search, the time complexity will be log n. So ideally this algorithm is much better than the linear one. Binary search will be efficient as compared to linear search. Okay, let us write the logic for the same. Yeah, so ideally what we are doing, we are traversing through the array. We have to find out the mid element, then we have to shift left and right positions. Do let me know if you are not understanding any part. Okay, yeah. So very first what we will do, we will find out the middle element of the array, right? uh, Here we are not required to traverse as well, because directly we will find out left and right element, right? So yeah, initially what you will do, you will find out the middle element. So mid will be equals to, yeah, your mid will be equals to initial value plus the length of the array divide by 2, right? Or what you can do is you can find out the like initially you can give left and you can give right. So my left will be the first element, right? This one I will consider as a left, and this one I will consider as a right. Okay, so left index will be 0 and right index will be length minus 1. Okay, so left I'm considering as 0 and right I'm considering as a dot length minus 1. So I'm taking initial indices. So left index will be 0 itself and right index will be length minus 1. Okay, if my length is 5, it will be 4. Okay, okay. We have to shift left and right. Correct. We will find middle element. If it is not the one which we are expecting, then the right from this position will move to this position. Right. Initially my right was 6. From 6 it will become 8. So we are shifting the left and right pointers. Okay. If it is bigger than the middle element, then my left index will shift from 0 to 3. Right. So we will add the same logic. We will add one while condition over here. L is less than equals to R. So left and right should not overlap. So that's why I'm giving the condition as left should be less than equals to right. Okay. Then we will find out the middle index. Okay. So mid will be equal to L plus R divided by 2. Okay, so we considered left index as 0, we considered right index as length minus 1, then we calculated the mid index. How we calculated that? We just added left plus right and we are dividing it by 2. Okay, then we will add the condition over here. So if the element at middle index is the one which I am looking for, so a mid equals to the element I'm searching for, then I will simply return the index, right? Or else I need to shift left and right pointers, correct? We have missed the data type over here. Okay, yeah. So yeah, if it is not the one which I am looking for, if it is greater, then I will shift left index from this position to mid plus 1. So mid is at second index, so it will become 3, left will become 3, and if it is smaller, I will shift right index. Okay, so initially my right index is length minus 1, so that will become mid minus 1, so it will be 1 ideally. Okay, so adding the same logic over here, else, yeah, else if my element is greater, so which index I need to shift ideally, which index I need to move left or right, which index I will shift, my element is greater, so I will shift left index or right index. Left will be shifted, right? Left is initially at 0th index, so my element is greater than the middle index, so left will be shifted to mid plus 1. Okay, so here it will, L will become mid plus 1. Okay, yeah, or else if my element is smaller, else if my element is smaller than the mid value, so simply what I will do, I will shift the right index, so R will become mid minus 1. Okay, yeah, so this will be ideally our logic, and if element is not found at any of the index, then we will simply return minus 1. Okay, so by both the algorithms we are searching the element, but the logic for both of them is different. Here we are directly cutting out the search space by half every time. Okay, let's once execute this program. So this was through binary search. Now we will execute the, this was through linear search. Now we will call out the method which we have created for binary search. Yeah, let's say I'm searching the element 7. We have, yeah, A, and let's say my element is 7. Okay, yeah, let's run this program. Yeah. Just a minute. Hello, am I audible? Before that, we have to pass the sorted array to this. There was some network glitch, I think. Am I audible and visible to you? Yeah. So let me call out the function which we have created. So binary search, and the element which we are looking for is 7. So we are returning the value itself. Let's run the code. So 7 was not there in our in the array. So that's why we have not received any output over here. Let us pass 8 once. So we have got the respective index which is 3. Okay. Simply what logic we have added? We have one left pointer and one right pointer. Left pointer is initially at index 0. Okay. And right pointer is initially at index length minus 1. Then we are calculating the mid index, and based on that we are checking whether it is containing the element which we are looking for. Then if it is not the one which we are looking for, then we need to shift left and right pointers. If it is greater than the one which we are looking for, we will shift left pointer, and if it is smaller we will shift right pointer. Okay. So our search space becomes ideally half of the one which we are traversing with. Okay. Is this algorithm clear to everyone for binary search? So this algorithm takes the time complexity of log n, okay, which is better than n. So that's why it is more efficient. Binary search is more efficient than linear search. Okay. Is this clear? Simply we are calculating mid position, and we are looking the element. If it is found, we are returning the index. If it is not found, we are checking whether it is greater or smaller, and we are shifting left and right indexes. Okay. Okay. Let's proceed ahead. Okay. So that was about time complexity. It is ideally how much time your program takes to execute with respect to the input you are providing. Okay. So we represent that with the help of the graph between the time and the input data. So we can say that it is ideally the rate at which the time increases, the rate at which time increases with respect to the input given. Okay. Coming to space complexity, it is the variables which you are using in the program. Okay. And how much space those variables are occupying. Okay. So ideally when you develop the code, you have to create only those number of variables which are required in the program, so that less space will be occupied by the program. Okay. You don't have to create additional variables or take up extra space which is not required. Okay. So ideally this here only one array is utilized. Here in the linear search only we are utilizing one array, and ideally we are creating uh, like one more variable is passed as an input over here. So the space complexity of this will be O of 1, because only single array will be utilized. So space complexity is not much the concern, but ideally while developing the logic you have to consider the variable creation such that no more variables are used, only those required to develop the program logic, and those which are required uh, throughout the logic creation, and uh, those which are necessary, those only are created in your program. Okay. So space complexity is about the space which are used by the variables you are creating in the program. Also like if you are using two for loops and multiple variables are used, unnecessary variables you are creating for storing the data temporarily, that will also occupy more space. Okay. So the example which I gave in case of a string, so let's say you are using the string which is modifying multiple times, so it will create 10 different objects, right? So that will be like unnecessary usage of 10 different values, yeah, or 10 different objects, which is not required. So we have to consider writing the program so that it will occupy less space. Okay. and also it is efficient. It will have better time complexity. Okay. Yeah, so that was about time and space complexity. uh, yeah, is it understood? Like, is the topic understood, concept understood to you? Can we move ahead? We will move ahead to the sorting algorithms then. Is everyone involved throughout? Yeah, you have to be interactive and you have to ask me questions as well. If you are not understanding, you can ask that thing. Okay, but make sure that you will understand everything. Okay, because these are very very important concepts with respect to interviews and with respect to data structures and problem solving. Okay, let us move to the sorting algorithms. So what is sorting ideally? What do we mean by sorting? So it is like to sort the data. Here we have provided the sorted array as an input, right? But ideally this won't be scenario every time. The data is not sorted, right? We have values randomly placed. Okay. So we will develop the logic which will sort the values of the array, which will sort the input which we are giving. So there are multiple sorting algorithms which are important part of data structures again. Okay. So, can you suggest few algorithms which you are aware? Sorting is like converting them into ascending order. Lowest element will be first, and likewise, it will go ahead to the bigger element. Okay. Okay. You want to revise me the logic for the binary search? Yeah. So, in case of sorting, we sort the data into ascending order. Lowest element will be placed first, and it will go ahead till the largest one. Okay. So there are few sorting algorithms. Are you aware of any? Yeah. So you have correct. You have correctly suggested over there. We have bubble sort. We have insertion sort. We have selection sort. We have merge sort. We have quick sort. We will be covering few of them in today's session. Yeah. So let us move to the first sorting algorithm, which is bubble sort. Okay, so what is bubble sort? Are you aware what is bubble sort? So in case of bubble sort, ideally we compare adjacent elements. Okay, so let's say this is my input array. So as we are proceeding with sorting, we will take one unsorted array as an input. Let's say this is my input array. Okay, yeah. So I will be proceeding with bubble sort for this. So in case of bubble sort, what we do, we compare the adjacent elements. From the start, we keep on comparing adjacent element and move we keep repeating this process unless we get the entire array sorted. Okay. So initially we will compare 7 and 3. So these two elements are not sorted, right? So simply we will do what? We will do swapping between them. So 3 and 7 will be swapped with each other. Okay. So after first iteration, my array will be like this. Then initially we have compared these two adjacent element, we have swapped them. Then we will compare these two adjacent elements. So these are already sorted. So swapping is not required in this scenario. Then we will move one step ahead. We will compare 9 and 1. So likewise, we will go one step ahead and we will compare the two adjacent elements. Okay. So this one is not sorted 9 and 1. So we have to swap 9 and 1. So 1 will come over here. 9 will move to the position of 1. Now we will compare 9 and 10. So 9 and 10 are again sorted. Swapping is not required. Then moving one step ahead, we will compare 10 and 2. So 2 is smaller than 10. So here swapping will be required. 2 and 10 will be swapped with each other. Okay. So this will be my first cycle. In my first cycle, I traverse through the entire array. I compare the adjacent elements, and if they are not sorted, I have swapped them. Okay. So this is like first cycle. You have to again do the swapping again. So this after first iteration, I will repeat the same process. But what has happened? Can you observe one thing over here? The element which was largest has come to the end of the array, right? The 10 was largest among the all, so 10 has come to the end position, so we don't have to sort that again. So next, in the next cycle, when we will perform sorting, we will only sort elements till here. We will only perform comparison till here, because 10 is already sorted. 10 has came to its correct position, that is the largest element has came at the end, correct? So in the second phase, we will first compare 3 and 7. They are already sorted, so swapping is not required. Then move one step ahead, compare 7 and 1. Here swapping will be required, so it will become 1 and 7. Then we will compare 7 and 9. Here they are already sorted. Then we will compare 9 and 2. Here sorting will be required, so it will become 2 and 9. So here again you can notice the second largest element has came to the correct position. Okay. So initially what happened, 10, which was the largest among all, it came to its correct position. Then we perform swapping again. Then 9 came to the correct position, that is second largest element came to its correct position. So in the next phase, we have to only compare this element. We will not check 9 and 10 because they are already sorted. So we will do comparison till here only. We will first compare 1 and 3. We have to swap them. So it will become 1 and 3. Then we will compare 3 and 7. They are already sorted. 7 and 2, we have to swap them. So 2 and 7. So again the largest element, the third largest element has came to its correct position. That's why this algorithm is called as bubble sort. So after every iteration, the biggest element comes to its correct position. Okay. The largest element comes to its correct position. It bubbles out to the end. Okay. That's why this algorithm is known as bubble sort. After each iteration, we are bubbling out the biggest element to the end. Okay. So now in next iteration, 7, 9, 10 are already sorted. So we will perform swapping till here only. We will compare 1 and 3 first. They are already sorted. Swapping is not required. Then we will compare 3 and 2. Here swapping will be required. So 2 and 3. Okay. Then we will not move ahead because these elements are already sorted. Okay. Then all this have become already sorted. Then in the next phase, we will compare this two. Okay, these elements are already sorted, so the swap is not required, and this will end up the entire swapping phase. So how you need to proceed with? You have to initially start by comparing adjacent element. In the first iteration, the biggest element will come at the end. So in the second iteration, you will not compare the last element. You will skip the last one. You will perform comparisons till second last one. Then again you will do swapping. Then the second last then the second largest one will come to its correct position. Then you will do swapping to the remaining elements. Likewise, you have to keep on doing the same position until you get the entire array sorted. Okay. So that's how bubble sort works. And why it is called bubble sort? Because after every iteration, the biggest element is coming to the end. It is coming to its correct position. Okay. Yeah. So here I have given one example over here. So initially 5 and 3 are there. So 3 is smaller. So here we will do swapping 3 and 5. Then 5 will be at this position. So 5 and 8 swapping is not required. Then 8 and 4 swapping is required. 4 and 8. Then 8 and 6 swapping will be required. 6 will come over here. 8 will come over here. Then your biggest element has came to its correct position. It has bubble out to the end. Okay. This is just the first iteration. Then you have to again start from the initial stage. But in the second iteration, you will not go till the last position, because last position is already correct. It is already sorted. You will you will keep on comparing till here only. Then in the next iteration, you will compare till here only. Then in other iteration, you will compare till here only. So this algorithm is known as bubble sort. In case of bubble sort, we compare adjacent element and we do swapping if it is required. Okay. And after every iteration, the largest element comes to its correct position. It comes to the end. That's why it is known as bubble sort. Okay. Is this clear? The algorithm is clear. Then we will move to the logic part then. Hello. Can I get responses? Is the algorithm clear to you for bubble sort? Okay, so let us write logic for the same. We will pass array input over here. Okay. Yeah. So in case of bubble sort, we need to identify the number of iterations we will be performing, right? So for that, we will create one for loop for all number of iterations, for overall number of iterations, like from here till here. Likewise, we have to do iterations till how many times? Length minus 1 times. Okay. So my initial for loop is for number of iterations, and it will go till length minus 1. So overall, this many number of iteration, this many overall iterations you have to perform. Okay. So this for loop is for number of iterations. Okay. N is, we can say, the length. We can declare it over here. Okay. Yeah. So length minus 1, this many iterations you have to perform overall. Okay. So if you are having 6 element, so overall how many iterations you will be doing in total? 5 iterations you have to do. Okay. Yeah. Then inner for loop will be for comparing the adjacent elements. Okay. So if my first iteration is going on, then I will compare the adjacent elements, right? So we will have one more for loop in that scenario to compare adjacent elements. So this will go till n minus 1 minus I, because I is like that element will be sorted in that iteration. So in my first iteration, no elements will be sorted. So minus I means minus 0. I have to traverse through everything. But in my second iteration, one of my element will be already sorted, right? So in that scenario, I will not go till that element. Okay. So that's why we are doing minus I over here, because that element will be already at its correct position. Okay. We will take some another variable over here. Yeah. And J++. So simply we are writing the algorithm for bubble sort. Outer for loop is for overall number of iterations we will be performing. So those number of iterations will be length minus 1. So if I am having 10 element, I will have to perform 9 iterations. Okay, then this inner for loop is for comparison. Okay, we have to keep on comparing adjacent elements, right? And I have given the condition that it should go till n minus 1 minus I. Why minus I? Because after my every iteration, one element is becoming sorted. It is already at its correct position, so we don't have to recheck that, revalidate that. So that's why I have given minus I over here. But for first iteration it will be minus 0 because none of the elements will be sorted. For second iteration it will be minus 1 because one element would have been already sorted. Okay, yeah. So let us give that condition over here by which we will compare the adjacent elements. Okay, so a of j is less than a of j plus 1. It means my current element is smaller than my next element. So 5 is, if my 5 is smaller than 3. Okay, or yeah, or we can give the, see, my current element is greater than my next element, or we can give in the opposite manner. My next element is greater than my current element, then I have to perform swapping, right? J plus 1, it means 3. 3 is, ideally if 3 is greater than 5, then I will do swapping in this scenario. Okay, so when I have to swap, if my j is greater than j plus 1. Okay, current element is greater than the next element. So how do we do swapping? Simply we have to declare one temporary variable. We will put the value of j plus 1 into that variable. Then we will swap over here. Yeah. So my current element is greater than my next element. My current element is greater than 5 is greater than 3. So we need to swap. So for that we have added the logic for swapping. We will put j plus 1 into temporary variable. Then inside j plus 1 we will put the value of j, a of j, and then in a of j we will put the value of temporary variable. So this is simple logic of swapping. Okay, yeah. So this will ideally swap the adjacent element if current element is greater than the next element. So in this scenario it will do swapping. So after the swapping will be done, we will get the elements at the correct position. Okay, so this will be our logic ideally to perform bubble sort. Okay, let us print the array after sorting. We will print the array after sorting. Yeah, so let us call out this function. We will pass the unsorted array as an input. Let's say this one. Let's run the code. So I have given the unsorted as an array as an input, but the output I have received is the sorted array. All the elements are sorted in ascending order. And I have used which algorithm for the same? I have used bubble sort. So what we are doing in bubble sort, we are simply comparing adjacent elements, and if the next element is greater than the smaller one, I'm just swapping the adjacent elements. Okay, we have to keep on doing this for n minus 1 iterations. So if your array is of size n, we will do the same steps for n minus 1 iterations, and after every iteration our last element is getting sorted. So that's why for for comparison thing we have added this inner loop, and this inner loop is going for n minus 1 minus I times, because my ith element is already sorted. Initially my last element will be sorted, then my second last element will be sorted, then my third last element will be sorted. So I will not be comparing those elements and will not swap them. Okay, we can optimize this solution more. Let's say if my array is already sorted, if I'm not doing swapping, so we don't have to perform this operation. We don't have to keep on performing this operation, right? So for that we can declare one flag over here to check whether the swapping is performed or not. Okay, so I'm just declaring one variable swapped. Okay, so the value of swapped will be false over here. So if we will perform swapping, then we will change the value of swap to true. Okay. So if we will do swapping, then only the value of this swapped variable will be updated to true, or else it will be false only, right? So if it is not getting modified, then we don't have to perform this inner iteration, right? So for that we will add one additional condition over here. So if the value of swap is equals to false, then I will simply break. I will not go into like inner loop and will keep on executing the inner logic, right? That means my array is already sorted. The value of swapped variable is not getting updated to true. It means my elements are not getting swapped. So in that scenario I don't have to keep on performing this logic, right? So simply what I will do, I will break over there itself. So my inner for loop will skip, it will not further execute. Okay, it means my further array is already in sorted manner. I don't have to again perform the iterations. Okay, because I'm not continuing with the swapping thing. It means my array is already sorted, my further array is already sorted. So that's why I will directly skip the inner iterations. Further iterations will be skipped in this scenario. Inner for loop will not continue ahead. Okay, so for that we have added this condition for optimization thing. Okay, so that the further executions will not be done. Okay, let us rerun this logic. So it will simply decrease the steps. Okay, if your array is already sorted, then you don't have to perform additional steps for revalidating and rechecking the adjacent elements. Okay, inner for loop is for checking the adjacent elements, right? But if my array is already sorted, then I don't have to keep on comparing the adjacent elements. Okay, so that's why we have added this flag to check the same. Okay, so that additional steps will not be performed over here. Okay, is this clear how we have implemented bubble sort? Simply what we are doing, we are comparing adjacent element, we are swapping if they are not sorted. Likewise we will keep on doing the iterations for length minus one time. Okay, yeah, is this clear to you? Is the logic clear? Is the optimization condition clear? Can we move ahead? So this is like one of the algorithm for sorting. Like that, we have more algorithms as well. We have insertion sort, we have selection sort. In case of selection sort, yeah, you will need practice for the same. What will be the time complexity? of this algorithm? Can anyone help me with that? What will be the time complexity? We are using two for loops, and that too this for loops are nested for loops, right? So what is the time complexity ideally? N square, because nested for loop is used in this scenario. So is this that efficient? Is this algorithm that efficient? No, right? We have to find out such algorithm so that the time complexity will be better. It will be somewhere between this. Either it will be log n or it will be on, right? Yes. Okay. Correct. Correct. N square. Yeah. So every time when you are given some problem, you have to think of the solution so that the time complexity will be efficient. It will be better. Okay. It should not be towards this side, but it should be towards this side. Okay. We will discuss few of the practical questions for today. Okay, so we will cover few array based questions, and later on then we can wind up then. Okay, we will be drafting the solution so that the time complexity will be better in that scenario. Okay, you will help me with the logic for the same. Yeah. uh, okay, let us say we want to find, let's say we want to find out, we want to write the program uh, to remove the duplicates from sorted array. What will be the logic according to you? How can we remove the duplicates from sorted array? Every time when you are given some problem statement, you have to think of the logic first. Like, what is my input? What is my output? How will I get that output? Okay, you have to think in that way. Okay, and also when you will draft the solution, you have to write the solution so that it will be efficient. Okay, the time complexity will be better. Bigonotation you have to give time complexity in that scenario. So you have to think in that manner. Okay, so let's say I have to remove duplicates from sorted array. So what will be the input in this scenario? Let's say I have got some input as I have the array with this values. Okay, so this is my sorted array. I have to remove the duplicate. So my output will be what in this scenario? It will be like 3, 4, 6, 7, 9, and 10. So this is my input and this will be my output. So you have to think of the solution. How will I get this output? What will be my logic ideally? Correct? Yeah, by mistakenly I have just a minute. I will rename it later. Okay. So how will I get this output ideally? Yeah, I will traverse through the array. I will make the temporary. Someone has suggested to create the temporary array to add the elements. So that will take more space complexity, right? You have to create one additional array. You have to create one additional array and you have to only take the unique values, is what you are suggesting, right? Okay, instead of that, what we can do is we can use pointers in this scenario, right? One pointer will traverse through my values. Pointer is nothing but the variable, so ideally we will declare two variable. One variable will be my one pointer, like it will behave as a pointer and it will traverse through my values, and another variable will store the indexes of unique elements. Okay, it will be only incremented if my element is unique. Okay, let us write the solution. So ideally what I'm saying is I will create two pointers, p1 and p2. My p1 will traverse through my array elements. Okay, it will traverse through each and every value, and p2 will only be incremented if the value is unique. So initially my p2 will be 0, then my p2 will become 1. Okay, then p2 will not change because the same element has came. Okay, then for 6 it will be updated. Okay, so p2 will ideally store the indexes of unique elements. Okay, like that we can draft the solution. Let us write the same. Remove duplicates. Let's say we will take one array as an input. So as we have discussed, what we will do, we will declare two pointers. The initial value of both of them will be 0. Both of them will initially point to the first value, right? So the index value 0. Okay, then okay, then we have to traverse through the array. Okay, we have to go till the length of the array. Yeah, so I have to take only unique values, right? So my p2 will ideally point out to that. I will increment p2 only if the value is unique. If the value is similar, then I will not increment it. Okay, so for that what I will do, I will simply compare the adjacent element. If my current element is similar to the previous element, I won't increment p2. Okay, so that will be my logic ideally. And we will be storing the element from current index to the p2. So let's say my current index for 4 is 3. Okay, but p2 is pointing to my unique indexes. Okay, so p2 is pointing to, like, let's go one by one. Initially 3 is unique, so p2 will be 0 itself. P1 is also 0. Then move to next position 4. Here 4 is unique, so p1 and p2 both will be incremented. Then coming to third value, which is 4. So in this scenario 4 is repeated. We will compare this with the previous element, so we can see that it is repeated, right? So in this scenario we will not increment p2 because p2 is pointing out to the unique indexes. Okay, so p2 is initially at second index, so we will not increment p2. We will move to the next position 6. So this is now unique. So in this scenario we will increment p2, and we, instead of the current index, we will place p2 at this index now. Okay, so it was previously at index 3, now it will come to index 2. Okay, so ideally my second pointer is keeping track of the unique value indexes. Okay, yeah, so we are not required to use p1 as well because we already have I. So I is traversing through the values, right? So no need of another pointer because I is already traversing through the values. Okay, so what we will do to get the unique elements, we will compare with the previous element. Okay. Yeah. So we have to compare with the previous element. So we will give condition accordingly over here. So if a of I equals to I plus 1. If my current element is equal, or what we can do is we can start from the second element. We can start from 1 over here, and we can check for the previous element. I minus 0 equals to I minus 1 equals to A of I. So current element is compared with the previous element. If they are similar, if they are equal, then I will not increment pointer P2. But if they are not, I have to increment. Okay. So ideally we have to write the logic for changing the index only when we have got the similar values. Okay. If they are not equal, I will increment P2. Okay. So initially P2 is at 0th index. After incrementing, it will come to position 1. Okay. Yeah. We have changed the index, but we have to replace as well, right? We have to shift the element from index 3 to index 2, because we want only unique elements now. Okay. We want unique elements over here. So we have to shift the element at index I with the element index P2. Right. We have to do that shifting as well. So we will add that logic over here. Okay, someone is asking in the chat, ma'am, we can't just select one element in array iteration order wise and iterate that one element to check if an element occurred is equal to it or not. But we have to like remove the duplicates, right? How we can do that by the logic you have specified? Like we have to compare that one element with all other elements. That will be complex, right? Here we just have to remove the duplicate. So that's why I'm just comparing current element with the previous one. Not every element, I'm just comparing this element with its previous. If it is similar to the previous one, it means it is duplicate, right? If my current one is similar to the previous one, it means it is duplicate. So if it is duplicate, then I will not increment pointer P2, and in other scenario I will increment pointer P2, and I have to shift the position of 6 to new index, which is of pointer P2. Okay, so we will do that shifting over here. We have changed the index, we have to do the shifting as well. Okay, so let's do that over here. So initially my 6 was at third index, it will now jump to the second index, right, after shifting. So I'm just doing the same thing over here. So initially my element at position A of I will be shifted one position back, or else what we can do, we can simply skip that element and will place the next element at the current position. Okay, our pointer 2 will swap the elements one position ahead. Okay. What will happen if the order we want is more shifted? Didn't got you. Hello. Hello. Hello, am I audible? Yeah, let us complete this logic. Yeah, so here we are comparing it with the uh, okay, so here as we have taken pointer p2, we will compare it with the p2 itself, because pointer p2 is tracking our value I, and p2 we will compare over here. Yeah, here we will increment, and if required we will swap. We are using a for array declaration over here. So p2 is my pointer which is only storing the unique values. Initially it is 0, so it will compare my previous value with my current value. Okay, so my current value is not equal to my previous value. So in that scenario I will increment pointer and I will place that element to my unique array index. Okay, and unique array index is tracked by pointer p2, so that's why I'm using p2 over here. Okay, and ideally whenever non-unique elements will be found, it will be incremented by 1. So p2 will only keep the track of unique values. Okay, and likewise it will remove the duplicates from the array. Okay, let us see the output once. After entire operation, I'm explaining the logic again so that you will get it in better manner. Yeah, let us call this. We have done the mistake over here. So ideally after 3 it has placed the similar value for all the elements. So some logic is missing over here. We are incrementing I. Just a minute, let me check. Second pointer is pointing out to the unique values. So here I will compare current element with the pointer value. Okay. Uh, yeah. Mm, 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 mm. So ideally,